And they have these yeah, it's like this really
Hi everyone. Yeah, so we'll start right now. Thanks so much for coming. Just to reintroduce myself, my name is Clemen, and I'm the head of modeling at ICDSS. Today's lecture will continue our series on building data platforms, and today we'll be focusing on data wrangling and ETL. ETL stands for extract, transform, and load, and we'll share more about what that is in the next few slides. So I assume that there is a proportion of you that are that weren't able to watch the video or come for the previous lecture. So here's briefly what we covered. We talked a bit about the concepts underlying cloud architecture, and we also discussed about Cloud Development Kit, which is a framework for building infrastructure using code in AWS. We also went through the process of building a simple web service using services like Lambda, API Gateway, and DynamoDB. So these are some of the services that we covered previously. Other than the hit counter, we also went through the building of a simple e-commerce application, which used a n-tier architecture. So before I carry on, I just want to go through some of the databases and their types that we used previously. The first is Amazon RDS, or Relational Database Service. RDS is basically a service that allows you to run relational database management systems. You may have heard of MySQL, Postgres, and more. And this is what you can use Amazon RDS to run. And you generally use RDS when you want to model and query relational data. So here's an example of a entity relationship diagram. And when there's highly relational data, like that, for example, like in a typical organization, you could use a relational database management system to basically query and extract information from there. The second database that we went through was DynamoDB. DynamoDB is a NoSQL database, And that basically means that it uses a collection of key value stores. And in DynamoDB, data can be queried efficiently, but only in a limited number of ways. So here's an example of the structure of the DynamoDB schema. And as you can see, there's a primary key, and there are also the attributes. So the thing about DynamoDB is that it scales very efficiently horizontally. So if you don't have highly relational data, so just simple data that you need to extract, you can use DynamoDB for that. And it's totally managed because it's serverless. And just a reminder on what serverless is. Serverless means basically the underlying infrastructure is completely managed from you. So it's abstracted away, and you just need to manage kind of the business logic. So these two databases are highly optimized for something we call online transactional processing, which stands for OLTP. And OLTP is basically analytics where it's extremely small individual transactions. It's kind of like when you log into Amazon, you need to retrieve your credentials, your username, and so on. So that kind of example is very individualistic. But of course, there is also another class of analytics that is more large scale, where we need to scan over large volumes of data to, for example, display on a dashboard, or even to do machine learning. And this class of databases perform what we call online analytical processing, which we'll basically discuss more in this lecture. So before I move on, I just want to also advertise the advanced analytics team. So we sent out a form on a WhatsApp group earlier this week, basically just to encourage people to sign up and join us in working with a startup to do some very cool AI product development and experimentation. So I'll just leave this for a few more seconds. And yeah. Okay, if you missed it, just catch it in the WhatsApp group. And if you need a WhatsApp group link, just let me know. So this is the big picture of how an organization's data architecture is like. So from left to right, there is source data coming in from IoT devices, social media, geospatial stuff like satellites. And the data comes in through streaming or message queue, which I'll share more how that's done later. This data goes into a data lake, and there needs to be some kind of processing that we can perform using services like Glue or other open source ETL solutions. And we transform this data from raw to processed. So this lecture really focuses on the process of transformation and what that really means. So this data is then taken in and used for other more value generating services, like, for example, machine learning, or for like visualization and analysis. So today's discussion really focuses on the role of what you would call a data engineer. And a data engineer just takes care of transforming raw data into data that can be used for various other purposes. And there's a lot of things that needs to be done for data to be used. In its raw form, it can be quite useless because data can be dirty, it can have very bad normalization, there are certain elements that we want to remove. And we can automate the process of transformation using tools like Glue, as well as Spark. And that will be the subject of today's discussion. So more about how streaming and message queue works. So essentially, streaming and message queue can be done using different services. We mainly talk about like Kafka, for example. And the difference is that message queue provides guaranteed delivery, whereas for streaming, we kind of focus more on low latency or real-time requirements. So as part of like designing the system, we kind of need to look at the requirements, and from there we can derive the correct solution to be used. But before I move on, I just want to kind of help everyone understand what really is data engineering. And this is the first example. The data can come in all sorts of garbage forms. when people fill out the form on Google Forms, for example, they fill up in all sorts of formats, and there is kind of no standardization. So there needs to be someone out there that automates the process of transforming this into more usable, standardized data. Furthermore, you could perform everything in Excel, but something will probably go wrong somewhere, or you're just gonna spend a lot of like needless time on it. It's much better to automate a solution using code. And the last point I want to bring up is that, lots of people kind of focus on machine learning, but there is a lot of underlying work that's needed before organizations can really kind of use ML to generate value of any sort. And a big part of that really comes in the form of data engineering and others. So yeah, back to the big picture. Today we'll focus on this part of that diagram, which is needed for that, which we'll focus more on next week. So just to kick the discussion off, I just wanted you to think, like, how do you process 1 GB of highly structured and clean data? Of course, this is kind of like typical of any standard tutorial in data science. You would kind of learn pandas, and then you learn how to use the data frame, and you would learn to manipulate the data frame to kind of drop certain columns and so on. So yeah, this works for 1 GB. You could even use Excel, and it would probably work as well. And you could use your own garbage computer, and it would work fine. But what if data kind of increases in volume from 1 GB to 1 terabyte? When you have IoT devices placed in rivers, in lakes, and so on, they're generating voluminous amounts of data, and that kind of builds up over time. The data can also be unstructured. It can be inconsistent, which means some form of processing is needed. And we find that our PC might not work as well. So we kind of need a new solution, which could be in the form of better computers like a Mac Pro, and also big data processing frameworks like Spark. So Spark is something that we'll go through today. It is a framework that basically is kind of like an engine that we can tap on to efficiently process large amounts of data. So what if data also increases to like 10 terabytes? Massive amounts of data. For a huge organization like Amazon, we're talking about very, very large volumes of data. And there needs to be a different approach to our strategy when it comes to processing this data. And one example might be to use Hadoop. So Hadoop is basically a file system that is designed for big data, distributed file system. You might also want to use ETL solutions like Glue, which allows you to abstract away the management of the underlying compute during your transformation process. But some organizations deal with even more data. We're talking about 1 petabyte. Data that comes in at extremely high velocity. And there is even more things that we can optimize to adopt this changing requirements. And one example is the use of MapReduce. So MapReduce was designed at Google, and it basically is kind of like an engine for data processing on large clusters. You might also want to use a data warehouse like Amazon Redshift, which we'll be covering more today. Because when you're taking like large amounts of data and you want to perform OLAP queries, there are a lot of optimizations that need to be done for it. So your typical MySQL, PostgreSQL probably won't fly. You need a data warehousing solution. So before we move on, let's kind of go through why organizations need to transform their data. The first reason is we really want to ensure a consistent quality within the data that we take in. Before the data moves on to downstream, where analysts or machine learning engineers or data scientists can take it in and use it for their own experimentation, there are a few like problems that we need to solve. Some examples include missing values, outliers, inconsistencies, and errors. And using Spark, for example, we can kind of automate the elimination of those. We also want to ensure that our data is highly consistent. So like previously, I showed you the example of a JSON with all sorts of different input from users. We want to harmonize that and make it consistent. The second reason is data wrangling can help us to do some simple feature engineering and exploratory data analysis. So it just helps us to better understand the data that's coming in. And this understanding in terms of, for example, what's in our schema and so on, can help us do better visualizations, better analysis, and better data science downstream. So our first part covers a deep dive into Apache Spark. We'll then go into what S3, simple storage service, and glue are. Then we'll talk a bit about Redshift and OLAP, or online analytical processing. And lastly, we'll go through a whole example of building a serverless data pipeline in Amazon CDK, which I shared about last week. The first thing, do I need to use Spark? Because I have pandas, right? Why would I need to use Spark? So Spark is optimized for large data sets. We'll go through the architecture of Spark later, but Spark is very handy when it comes to managing, few gigabytes, for example. It makes it very fast. Your data set is not big. Simple Lambda function with pandas might do. So in AWS Lambda, there's this concept of layers. So this is something I struggled with at first. I didn't know this existed because I was like trying to import pandas or something, and like the dependencies kept like giving me problems. So the thing to look up is Lambda layer, and this helps in like bring in packages into your Lambda functions like pandas. So what is Apache Spark? Apache Spark is a unified analytics engine for big data. Previously, people were using Hadoop, but Spark kind of took over. So people are just using Spark now. Spark's architecture consists of a leader and worker node. It also has a driver, and this driver basically takes code and then transform it into multiple tasks, which can then be distributed amongst the workers. And within those workers, we also have executors that are able to run and execute tasks. So this is the simple structure of Apache Spark. And the part that we really want to focus on understanding first is why Spark is so fast. So this is a Spark cluster. Yeah. So our driver program over here, it takes in user code, and it also starts a Spark session. And this driver program is also responsible for creating something called a resilient distributed data set, which is the fundamental data structure in Spark. So the driver program is also responsible for executing tasks, like I showed earlier, and basically distributing those tasks around the different executors. So previously I mentioned why Spark is so fast. And the reason why Spark is so fast is because it allows us to efficiently exploit the use of memory. So in a computer, there's the CPU, there's memory, and there's disk. If your data is stored in disk and you need to continuously fetch the data from disk, it's going to consume a lot of cycles and therefore time. So it's not very efficient. But if you're able to efficiently exploit the use of memory, this makes our processing much more efficient because memory is much closer to your CPU. So within the executor, there are different slots, and these slots basically take care of using the memory. So there's working memory and there's storage memory. So this is what a resilient distributed data set is. It's essentially a logical collection of data, and this data is partitioned across different machines. So yeah, the RDD is also immutable, and it is kind of the most fundamental data structure in Spark. So just hold on to this idea of like fundamental data structure, because later on I'll be sharing about Spark data frames, which is an abstracted version of the RDD. that we can use a very efficient querying to do. So you kind of use RDDs when you want to perform like fine-grained control on the data that you're processing. So last week I taught about CloudFormation and CDK, and our CloudFormation is kind of like the raw form of infrastructure as code, and CDK is like where you can use programming languages like Python to basically like programmatically create your infrastructure. So RDDs and data frames are kind of like the same idea. So RDDs allow you to perform a very fine-grained control over your data, but typically people would use like data frames. So you can perform different functions on RDDs. You can do select, you can do read, you can do filter, and so on. But we kind of focus more on data frames. So this is kind of some code on how you would create an RDD using PySpark. And as you can see over here, given some data, we can just create an RDD as an object, and then we can run different Lambda functions on it. So yeah, you can basically from there manipulate the data within RDD. So let's move on to data frames. It kind of is a similar idea to the data frames in Pandas in that you're able to manipulate the data within the data frame, and it's much easier to work with than RDDs. So for example, over here, using Spark, we basically do the same thing. We create a data frame given raw data, and we can then run different functions on it. But the key thing I really want to focus on is the idea of like running Spark SQL. So over here, for example, we're able to use Spark SQL to do functions like average. This is something you can't do using an RDD. So with this, essentially, it means that you can run SQL queries extremely efficiently on large volumes of data using very simple code like this. So that's basically why we need Spark, because Spark helps you to simplify large, like big data processing. So hold on to the idea of Spark data frames, because later on, when we talk about Glue, we find that Glue actually uses Spark. And it uses Spark in the form of this data frames idea to go and do the processing. So when you write your transformation code using Python, you would basically use, like for example, this to go and transform that code. And with Spark, you just upload the code to AWS, and it'll just run the processing for you. So we need Spark because when we do large data processing, we can also use EMR, which stands for Elastic MapReduce, to basically set up MapReduce clusters and then use PySpark to kind of do the same thing, which is large data processing. So before I move on, I just want to compare and contrast EMR and Glue. So Glue is kind of like a fully managed serverless ETL service, whereas EMR is a service that we can use to set up clusters, which can then process and analyze large data sets. So there is a lot more initial effort when it comes to Amazon EMR, as well as cost. So that's why I guess some people would choose to use Glue to start with. So what is Glue? Glue is a serverless data integration service. And with this service, we are able to discover, prepare, move, and integrate data for analytics, ML, and so on. So let's break that down. There's discover, there's prepare, there's move, and there's integrate. So discover is kind of very important because when you take in a large data set, it would kind of be useful if there was some automated service to crawl that data and extract information such as the schema or other metadata about the tables. So Glue kind of helps us to do that. Furthermore, we're able to also use Glue to upload, Spark code to go and transform that data and move it from a source to destination. So this is very important because, for example, if you're taking data from your raw data S3 bucket and then moving it to a processed data S3 bucket, we kind of use glue to simplify the whole process. So furthermore, we were able to create workflows. So one ETL job is kind of like one workflow. And then we can trigger and orchestrate those workflows using other AWS services like EventRich and more. So we'll go through that in our example later. So we're able to crawl data, as I previously mentioned. And then we can also store the metadata that we have kind of extracted from the tables into something called AWS Glue Data Catalog. So the idea of crawling is basically to access our data in the source. So the source can be an S3 bucket. And then from there, we're able to extract the schema and metadata and create definitions into data catalog. So this is very important because later on, we're able to simplify the use of Spark when our metadata has already been stored into data catalog. And you'll see an example of this really soon. So for example, if I was given a massive JSON file consisting of, for example, this kind of schema, we want to extract data from the JSON file. So as you can see over here, there's kind of three distinct groups of data. There's like, persons, memberships, and organizations. And we kind of want to store this metadata somewhere. So Glue helps us to automatically extract the schema and also store the schema into data catalog. This later on makes transformation very easy. So for example, if you wanted to like denormalize the whole database, we can do that using Spark and tapping on the extracted metadata from this original JSON file. So kind of what I just said, we basically store metadata into data catalog. So this is the example over here. Basically we I'm not sure whether you guys can see the code. It's kind of small, but basically the idea is that we have extracted the metadata from the original JSON file, and we subsequently use it to perform transformations like dropping or renaming certain fields. So if you want to like look at the full code for this, the link is down there. The slides and everything we uploaded onto YouTube later on, so you can just check back later. So yeah, let's just move on. So the next thing is we'll be sharing about S3. S3 stands for Simple Storage Service. It's a really important service to know because it's part of many architectures. And what S3 is, it's basically an object store. And as an object store, it is able to store stuff like photos, store videos, CSV files, or like JSON files. So it's kind of like whatever data you want to store, you can just throw it in S3 and it'll store it for you. And what's important about S3 is that it's extremely scalable. So if, for example, demand increases a lot for like services wanting to extract data out of S3, S3 can automatically scale to meet that. And it's also very durable. So S3 is kind of like triply backed up or something. So it's like distributed across different availability zones automatically. So it's basically highly resilient. It's also secure, provided you don't make the objects public. Yeah. So there's also this very useful property of S3 in that you can also tune storage classes. So there are different kind of storage classes on S3. So for example, there's S3 standard, S3 infrequent access, and S3 glacier. And what this means is basically you can store stuff you don't need for cheaper within S3. So let's say there's like files that you need to store, like for example, customer data, but you know that you won't really access it, what you can do is you can basically transit it into a different storage class. And that means that you can store it for cheaper and helps you to lower your total cost of ownership. So that's S3. Now we'll move on to Amazon Redshift. And Redshift is basically a data warehouse. So what is a data warehouse? A data warehouse is essentially a central repository of information. So we are able to store our process data after transformation from S3 into data warehouse like Redshift. And we can then use SQL or other business intelligence tools on Amazon Redshift to basically query that data. So why is Redshift so good? And how does Redshift really differ from other database types? So Redshift is highly optimized for OLAP or online analytical processing. And what I mentioned, OLAP is basically large volumes of data that you want to analyze, and it's kind of like used more for like long-term analysis. So for example, if we want to scan data from the database and display it onto a dashboard, Redshift would be highly optimized for that because we want to extract large volumes of data. And where they really differ, OLAP and OLTP databases, is that OLAP is more column-based. So it kind of has to do with the way that data is stored within the database engine itself. You can just Google like n-ary or like n-ary storage model, column-based, row-based storage models online, and you can find like more theory on that. But basically, for column-based queries, you would use OLAP databases. Whereas for row-based queries, for like a single row in the database, you would use OLTP. So this difference is kind of displayed over here. So we are basically going to describe the requirements of this project very quickly. And after I describe the requirements, then we can distribute the pizza, and I'll dive into the code with you guys. So the requirements is this. We want a data pipeline that performs checks and transformations whenever new data is uploaded into an S3 bucket. And the checks are kind of like this. For example, I want to check like one column in my database basically contains like only USD or has no missing values. So we want to programmatically do this. And we also want to like drop certain columns whenever there's a certain like input. And subsequently, we also want to transform the format from, for example, CSV as the input into Parquet. And Parquet is a different format that is easily consumed by data warehouses, for example. So we want to do all these transformations using PySpark. So I'm sure everybody here is kind of familiar with this workflow where we upload data into a raw data store. We subsequently trigger a workflow, which then transforms this data. And then we upload this transform data into a new object store where we keep all our process data. And this can also be a data warehouse. But in this example, we're just going to use S3. And the idea is basically, we're also going to crawl new data that comes in and then perform our ETL. So let's go into that. So that's our glue workflow. And that's where our ETL is. Our transformations are being done within the glue ETL job. And also, so our glue ETL job is responsible for performing all these transformations. And we'll see how we do that exactly using the CDK code later. If you want to open that now, the link is not really showing, but I'll just move it up later so you guys can see the code. The next thing is we also want to make this kind of an event-driven architecture. So remember all these keywords like serverless. Now this is another one. event-driven architecture. And what this means is this work is basically triggered whenever certain events happen. And in this case, the event is when we upload data into our raw data storage, which is Amazon S3. So using Amazon Event Bridge, which is another service, we're able to codify certain rules to basically trigger our workflow whenever something happens. And in this case, it's when users upload data. We also note that we don't want to basically recrawl the whole data set because it's massive whenever new data is uploaded. So we can also adjust our architecture to include a queue that is basically able to be pulled by the crawler for new files. And this queue can also be triggered by event notifications from S3. So an event notification is basically whenever something happens in S3, like a user delete or user upload, we can trigger a queue to start. So this also uploads the data catalog, which is used by our ETL job. So just to illustrate this whole thing, a CSV file comes in from the user, it's uploaded, and it's processed by AWS Glue, as well as the ETL job, transformed into a new format with all our requirements already transformed within, and it's sent into the process data storage. So if you want to see how this code looks like and follow along with me, you can just go to this link. It's going to move it up a bit. Yeah, link is over here. You can just kind of type it into your browser, and you can just follow the code as I go through it. So without further ado, can we just distribute the food and ensure everybody has like their dinner while we work through the code? Oh, still got boxes. Okay. In that case, we'll just go through the code first. Sorry? No, that's not mine. It's just an example I found online. Yeah. My GitHub.
Pocket and show it on your.
You can find my GitHub very easily. This is the repository. It's a very good example of CDK code that performs like ETL. It's kind of hard to find online because CDK is quite new, but it's kind of becoming the industry standard. So if you learn how to do IAC together with ETL, I think it's quite useful. So yeah, everything is kind of laid out around here. So let's go through the code. It's not too different from last week's one in that the structure of a CDK project is kind of the same all the time. There is basically a stack. A stack is basically an abstraction within CDK that consists of different services that you want to use. So in this case, we have one stack in our project, and this stack is Glue pipeline stack over here. So let's go into what Glue pipeline stack is. So you can see over here, we imported from the stacks folder. So moving into this Python file, I can see all the infrastructure that I'm using for this project. So over here, I just create a new class for this stack, and I lay out the different infrastructure that I'm using. So the typical process is you would go and plan what kind of services you want to use. You would plot it onto an architecture diagram, and then kind of like discuss with your team the pros and cons of this architecture. Once you've worked out that it's kind of like good, so it's effective according to the various ideas I've mentioned in the first lecture, then you would move on to kind of like create it out and develop it using CDK. So let's say this works. I know I need these different services, and I need to connect them in a certain form. So for example, I need to connect SQS with S3 via an event notification. I would codify this using CDK. So the first example is I would create a bucket, an S3 bucket, where I would dump in all my raw data. So all my raw data basically goes into here, and I can tune certain parameters of S3, which would suit the architecture. So one example is I can kind of like code in the lifecycle rules, because we know that our data, once we upload it in, it's quite likely that we won't use it ever again because it's raw data. So I can kind of like add in a rule to transition this data from the standard class to the glacier class, which is suitable for long-term storage and is much cheaper. And by the way, it's much cheaper because it takes more time to retrieve data out from glacier. So there is a con to transitioning data from one class to another, but I know that I'm not going to use it quite likely. So I can just transition it into glacier. I also create another bucket for my process data. So it kind of goes into here. And the next thing is I also basically create my SQS queue. So it's very simple. You can just use it over here like this. You can also add in the type of connection. So as you can see over here, CDK makes it very easy to connect one service to another, because the patterns in AWS or in fact in any other cloud provider are very common. It's kind of the same. So if you kind of like learn one cloud, you can just transition to another very easily. But anyways, I also basically put in IAM role. So for those that missed the previous lecture, it's very important for us to assign roles to the different like workers within our architecture, because this helps us to perform role-based access control. Like only some services can use like the data that they're supposed to use, and that kind of like ensures that our architecture is secure. So here I give Glue a role, and I give it a role that is enough for the different kind of work that it needs to do. And in this case, the work that it's doing basically deals with the use of, for example, it needs to access S3 because it needs to pull data out of S3. So I give it full access to S3. And from there, by the way, asterisk means full access. And from there, it's able to, read and write to S3. Of course, if you want to be more fine-grained, that's even better. So kind of don't give full access to something, only give it read or write access. So it also needs access to various other services, like I give it access to CloudWatch so that I can also monitor metrics. Also give it access to CloudTrail so I can see different logs of the API calls made by Glue. So the next thing is I also configure like more specific stuff about Glue. I add in a database. So a database is something within Glue where I store my different tables. It's just one configuration of detail. And I also add in my crawler. So over here, my crawler, as you guys have learned, the crawler just crawls the raw data and it extracts the metadata out like a schema. So over here, I create the crawler, and then I define what is the target of the crawler. So in this case, the target of the crawler is the S3 bucket and the event queue, which is the SQS queue that pulls for new files from the original raw data S3 bucket. We also are able to add in one configuration detail, which is the recrawl policy. So the recrawl policy is very important because crawlers consume money for every second they spend crawling new input data. So if we want to decrease the cost, we kind of need to make sure our recrawl policy is modified, and we modify it to only crawl when a certain event occurs. So the next thing is our glue job. So over here, we basically add in the script that we are using for this glue job. And we know that we are able to use PySpark. So we can then write all this code out, put it into a script, and then deposit the script somewhere. And CDK is able to take out the script from here, for example, and use it during their processing. So this automates the whole process And basically, yeah, it's very cool. So the next thing is the triggers. So, just more configuration details. And yeah. So the very important thing, I guess, that everybody wants to look at is what's in a glue job. So this is what the glue job is. This example doesn't use PySpark, but if you want to see like examples using Spark, you can go onto the glue examples GitHub. Just Google it on your browser. The one that I shown just now on the screen, where we took apart the JSON file, uses PySpark. So this example uses pandas because I guess the data is not as voluminous, but if it were, you'd have to use PySpark. So yeah, we basically define different functions of what our ETL job has to do. So the first important thing is to extract data out from the raw data source. So I do that using a function called getData from S3. And this basically takes out the data from S3 using the AWS Bottle SDK, where we can use like Python libraries to perform different like functions. Like if I want to take data from S3, I can just use the SDK for Python. So I basically take out the data. You can read through how this is done. Then subsequently, I perform the transformation. So the transformation is over here. As we saw in our requirements, we had to do a few things. So for example, we had to check our currency column. We also had to drop certain columns, and we also had to calculate the average from some of the other columns and then create a new column. We also needed to transform this data into the Parquet format. So over here, we basically do that using pandas. And yeah, it's kind of a pretty simple script, but it's just to illustrate how you would do this programmatically in Glue. So you would create a script, you would basically do your transformations, and then you would write out your S3, write out your data into the new format, in this case Parquet, and upload it into the destination, which is S3, like over here. So this is kind of the load process. So I hope you guys were able to see the whole ETL, all three steps in this example illustrated quite clearly. So without further ado, let's kind of like do a short demo. So I've already run CDK Bootstrap as well as CDK synthesize and CDK deploy. And what that does, for those that missed the first lecture, is it converts all this Python code into CloudFormation, and then afterwards deploys CloudFormation into the cloud, which will then spin up all the infrastructure that we have defined. And then from there, we have basically deployed the infrastructure. So I go over to S3. You're able to see a lot of my other stuff, but let's ignore that. We can see like our S3 buckets have been created. So over here, we have a raw data bucket and an S3 data bucket. So let's open this first because I'll need to use this. We also know that our glue stuff has been uploaded, but it's easier if I basically run the job first for everybody to see. So let's upload the data. So if I add my files, just very quickly, I'm going to go into my files over here. So this is the raw CSV file. So if I press upload, hopefully it'll automatically do the transformation in the background and then upload it automatically to my process data bucket. So I go to my connectors and I go to my crawlers. I can see that I do have a glue crawler. And this glue crawler is the one that we have created just now. So let's go to my S3 bucket. Probably shouldn't take much time because the data set isn't too big. If I go to my process bucket, okay, I guess it's still running, so it hasn't been uploaded. But basically, it will process, do the ETL, and then upload it automatically to S3. So the main point of all this is just to get everybody to understand what ETL is, because I guess it's kind of a concept that's not too commonplace. and actually see the code for how ETL is done. So yeah, this is a quite good example because everything is done in CDK. If you want to like go through the code at home, even like play around with it, you can just go to this link. I took it from some blog post because I don't have too much time. So yeah, you can just use that. Oops. So now, before I kind of wrap up the lecture, I just want to like kind of like give a short introduction to the next one with an opening question. And the question is how you would deploy a ML model, without any cloud services. You can kind of think of this as a very simple system design trivia kind of question. So we all know how to train ML models. I'm sure like a lot of you have done like, introduction to TensorFlow, introduction to scikit-learn kind of courses, where you take data in, you kind of create a random forest, and then you see, oh, it works nice, 90% accuracy. Then the tutorial ends, and then you go and learn something else. But we also need to think about the whole life cycle after the data has been used to train the ML model. So I'm just gonna say what it is. Data comes in, it kind of is fed to an API endpoint. So for those of you that don't know what an API endpoint is, we kind of went through it in the first lecture with API gateway. You can kind of think of it as a URL. We're able to query, we're able to do a request and response. So when I request, I send data to this URL. This URL links to and points to some sort of compute that does some computation. In this case, it kind of is more like the inference step of the ML model. Then it gets a result and it spits the result back as the response. So request and then response, that would be typically how you would deploy a machine learning model into production. When I say production, I mean not production, because that is a totally not good way, in the sense that it doesn't account for a lot of things when you deploy your model. So there are a lot of like other considerations that might not have been taken into account in that approach. It's kind of like the naive approach. For example, one thing to think about is your dependencies. I can serve the model up on my computer, like I can run a node server, but that's not very scalable, right? I kind of like want to have my ML model serve hundreds or thousands or even hundreds of thousands of users. And to do that, I kind of need a strategy. And this basically involves like packaging my code up into a Docker container and then deploying this container onto the cloud, onto Kubernetes, and then serving this up to all the consumers that want to use my ML model for inference. There's also stuff to think about like security and also how you would perform redeployment, because ML models get stale very easily. So we need to take in fresh data from engineering and then afterwards train new models and then redeploy it out. And there needs to be some form of governance for this whole ML lifecycle. And that's what we're going to go through next week with an introduction to Docker, talk about Kubernetes, SageMaker, as well as SageMaker endpoints. So if you're interested in that, I'll see you next week. And yeah, if not, for those that want to have the pizza, there's more coming. You can stay for a bit more. If not, you can help yourself to this first. Yeah, thank you so much.
Access to recording.
The recordings will be uploaded on YouTube by Sunday.